Okay, geometry. Oh man, it's been a week. I feel like I haven't seen a lot of you guys like all week. We're going to go through 7-4 notes, rectangles. This is going to be, and hopefully a nice, easy section for you. I'll give you homework here in just a little bit, but let's fill out the top right corner of this sheet. So you need this guy to fill him in, and we'll go ahead and add a couple more things to the rectangle side. So I'm going to first draw a picture. And one thing that I want to say about this is don't ignore this guy. This guy says that it has a star there and it says parallelogram. So that means that this rectangle is a parallelogram, which means he contains all of these 5 qualities already, right? Okay, so I'm not going to rewrite all 5 of those and put them over here. We're going to talk about them, but I'm not going to rewrite them. I didn't put a place for that, but I just put star parallelogram so that you know that all 5 of these things apply to that rectangle also. Okay, so here we go. For a rectangle, we know that the opposite sides are parallel. This guy's parallel to that one. This guy's parallel to that one. Okay, we know that the opposite sides are congruent. So this is the same length as that, and this guy's the same length as that guy. Okay, then we know that the opposite angles are congruent. Okay, so this angle is the same measure as that one, and this angle is the same measure as that one. We're going to talk more about the angles here in just a second, and add another little guy over here about angles, but there is that. We know that the consecutive ones, the ones that are right next to each other, like those two, add up to be 180. These two add up to be 180. These two add up to be 180, and these two add up to be 180. Okay, and then I also know that the diagonals, these guys, bisect each other. So they split each other in half, meaning like this chunk is the same length as this chunk, and this chunk's the same length as this chunk. Okay, so it's like splitting, each diagonal splits each other in half. Now, in addition to these 5 things, we have some other special things that we know about the angles of a rectangle that are not true about any regular old parallelogram. Okay, so we know that the angles of a parallelogram, the opposite ones are the same, right? But in a rectangle, we know that all 4 of them are equal, or that all 4 are 90 degrees. Okay, each one of those 4 angles is 90 degrees. They're all congruent to each other. Okay, so that is true for a rectangle, but not true for any old parallelogram. Okay, yeah. So then the other thing about the diagonals, so yes, the diagonals split each other in half, but also the diagonals are exactly the same length. This guy is the same length as that one. Okay, so I'm going to say diagonals are congruent. Now, that's not true in a parallelogram. This diagonal in that parallelogram is longer than that one, right? So any old parallelogram will not have those, but specifically a rectangle, which is a parallelogram, this rectangle will have those qualities, okay? And this kind of goes back to like a rectangle is a parallelogram, but not every parallelogram is a rectangle, right? So you're like, that's confusing. How can that be true? Like, whatever. A rectangle is a parallelogram, but not every parallelogram. Like this guy is not a rectangle. This guy is a parallelogram, okay? So I know sometimes it's hard to wrap your brain around, but just, yeah. That's how it works. All right, let's do some examples. Some things that we know. They have a theorem 713 here says if a parallelogram is a rectangle, then its diagonals are congruent. So we just said that. The diagonals will be exactly the same length for a rectangle, but not necessarily true for a parallelogram. Okay. All right, so using properties of rectangles, it says the coach is making the basketball team run a new drill along the diagonals of a court as shown. It says if BC is this guy right here, and that is 94. And FC, which is this guy right here, that is 106.5. Find DG. Oh, okay, DG is this little guy. I kind of ran him over. DG is that one. Okay, well, I know that if this is 106.5, then this is also 106.5. But I know that since he's a parallelogram, that this guy is cut in half, right? So like this length will be the same as this one, right? So I'm just going to take that 106.5 and I'm going to divide him by 2, and that is like 53.25 or something like that. Yeah, 53.25 is what he will be. And that is the length of DG. There you go. Okay. All right. One thing, let's see. Yeah, one thing that I want to talk about before we do the next example is this. Okay. So here's the deal. My husband used to. He's now a electrician, but he used to be a carpenter, and he would like build houses, like frame up houses, do all that stuff all the time. So when they go to build the walls of a house, they build like the walls on the ground, right? And then they stand them up, right? And so what they do is they do that, and then every 16 inches you have studs, that go through the walls. I'm sure you guys have seen this before. But anyway, so there's that. Now, that they want to be a rectangle. But the problem is sometimes just the way that, like, so when you put screws into the board, like you put the screws in, whatever, right? Sometimes you can't help it, but like that board slants just ever so slightly, right? Like this is even more exaggerated than what it probably should be, right? So sometimes that thing is just at an ever so slight slant and you don't know it. And when you stand the walls up, I don't know if you've ever seen like a picture frame that doesn't have glass in it, and you could tilt it like back and forth, right? Because the joints aren't necessarily like screwed together very well. Well, that's what happens to this frame. Like sometimes like the wind can blow and it can like tilt him on his side. So, or maybe when they stand it up, it's already kind of tilted. Like how do they determine and how do they make sure that it doesn't slant over? Because this can cause a lot of problems, right? Like my other wall's not going to fit with him and all the things, like that's going to cause problems. How do I make sure that this guy is a perfect rectangle? Well, a parallelogram and a rectangle will have all the same qualities except for what I can do and what my husband does. He does this every single time he frames a wall or anything like that. He will measure from here to here, and then he will also measure from here to here, and he will make sure that they're the same length. And if one of them is longer, he'll like use his hammer and like tap in one side until these guys are the same length, because if those diagonals are the same length, I know that's a perfect rectangle making 90 degrees. If they are not the same length, then this guy is like at a slant, right? And I want to make sure he's not at a slant. Sometimes it's slanted so much that like you can't even see it with your eyeballs. It's just like slightly slanted, but that can cause a lot of issues. So every single time he does anything rectangular, he will always do like he was making my kids' bunk beds one time, and he had to make the rectangular base or whatever, and he did this thing because he was trying to make sure that it was a perfect rectangle. Otherwise it's going to cause problems, right? So that is a thing that he has to look at, okay? And that is true for rectangles. So I just want to point that out. All right, let's go and do some more things. Example 2, they have quadrilateral ABCD is a rectangle. So we do know, in fact, that this is a rectangle. It says the measure of angle BAC. BAC is just this little top angle, okay? Just this little guy. That is 3x plus 3, okay? And then it says the measure of angle ACB. ACB. This angle right here is 5x minus 1. They want us to find the value of x. Okay, so I look at those two like angles and I'm like, okay, they make a little triangular guy, right? Okay, and there's 3 angles in a triangle. It's this one, and this one, right? But if this is a true rectangle, then I know that this angle is 90 degrees, right? And all 3 of these, this guy plus this 90 plus this guy, have to add up to be 180. But I can do better than that. If this is already 90, then these two will add up to be the other 90, right? 180. If I've already used up 90 degrees here, that will be the other 90. So I can just say 3x plus 3 plus the other 5x minus 1 has to add up to be 90, and I get it faster, right? You could have added the 90 in there and set it equal to 180, but go faster. All right, so 3x and 5x is 8x. 3 minus 1 is 2 equals 90. Let's subtract the 2. 8x equals 88, and then x is 11. And let's make 11. Let's make sure we don't have to plug back in. Find the value of x. Nope, x is 11. We're done. Okay, so we could plug back in and find what this angle is and this angle is, but we don't have to do that. So always check that to be sure, though. Okay, all right. Next, let's see what this one says. Diagonals of a rectangle. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. We just talked about that, okay? And that's why my husband, every time he's doing framing a house or doing anything rectangular, he always measures the diagonals. And if that's true, then it's not slanted like a parallelogram is. It's upright like a rectangle, okay? All right, example 3. This is a proof. I'm going to go I was looking through these examples. Instead of doing example 3 proof, I'm going to do the check proof because it's already in 2-column format. Like this one is like a paragraph proof, and I don't want to do a paragraph proof. I want to do a 2-column proof. So this one we'll just go through and we'll go through these steps, okay? So it says PQRS is a rectangle. So this guy right here, this overall big shape is a rectangle, okay? So I know all the things, right? Like I've got that in the back of my brain. These are 90-degree angles, right? Like these sides are congruent, all of the things, okay? I don't know what information I'm going to need, so let's just sit with that, okay? And then I also know that PT, which is this guy, is congruent to ST, so I know that those two guys are the same. All right, they want us to prove that QT, which is this guy, is the same thing as RT, okay? And so I'm looking particularly at these two triangles, and going back to like what we did in the last chapter where we're proving like by side, 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 or side angle side, or all the things, we are trying to figure out if those two triangles are congruent. And then if this triangle is congruent to this one, I can say that this guy is congruent to this one by CPCTC, which stands for congruent parts of congruent triangles are congruent. That's a lot of the word congruent, but CPCTC. If these triangles are congruent, then their matching parts or their congruent parts will be congruent as well. Okay, so that's what that says. That's CPCTC. So I am looking at these two triangles and I'm trying to figure stuff out. All right, so I know that this is a rectangle and that PT and ST are the same. That's giving me a side. So I'm going to put my inventory over here and I have a side already. This side is the same as that one. All right. Now, they say that by definition of a rectangle that this is also a parallelogram, which, yeah, that makes sense, but we'll put it down, all right? Now, if you use a parallelogram, then I know that the opposite sides of the parallelogram are congruent. Now, which opposite sides do I need to pick on? Like, am I interested in looking at this one versus this one? No, probably not. I want to show that this guy is the same as this guy, right? Like this opposite side of that parallelogram is the same because those are sides that are in my triangle, right? Now I've got two sides. Got it? Okay, so I'm going to put right here for my opposite sides, I'm going to say that QP is congruent to RS because those are my two opposite sides. Okay, now, let's see, they say by definition of rectangle, we have something going on here, okay? By definition, if that thing is a rectangle, something has to happen. But then I'm going to just jump to step 5 and see if we can bridge this gap. It says that angle S and angle P have to be the same, right? Angle S and angle P, because all right angles are congruent. So we must have said in step 4 that angle P and angle S are right angles. Why did I put angle? Are right angles. P and S are right angles because it's a rectangle, right? We know that that's a right angle if it's a rectangle. Now, also Q and R are also right angles, but we don't need those because those are not inside of my triangle, right? So particularly we're looking at P and S. Okay, now we can say, oh, I didn't fix my inventory. I should have a side here, right? Okay, S and P are congruent because all right angles are congruent. We just established that they are right angles. So now all right angles are congruent, so that is an angle. And these two triangles are congruent, so I'm going to say triangle, oh gosh, Q, let's go QPT is congruent to triangle RST. Okay, and they say by side angle side. According to my inventory, it looks like SSA or the naughty one, right? ASS. But if I look at the way that it's positioned here, the angle is between the two sides. So that is in fact side angle side. And then we can say that if this triangle matches this one, then of course this side has to match that one, right? So QT and RT are the same by that CPCTC. QT congruent to RT. There we go. Okay? All right, so that was a proof. All right, let's go do one more, and there is this example 4. So they're giving me these coordinates G, H, J, K, and they say use the distance formula to show that this is a rectangle. Okay, I'm going to do it over here. So I'm going to do the distance formula. And you guys are going to be really yucky about this, but whatever. I can't sit. I don't have to hear you complain because like not around you, so we don't care. All right, distance formula. So first, you're not going to like this, but first we have to show that this side is the same as this one and this side is the same as this one, right? Like we have to show that the opposite ones are congruent. That is 4 distances, okay? Now, the problem is if I show that this is the same as that, and this is the same as that, that only makes him a parallelogram. So how do I know that that parallelogram is a rectangle? Then I have to do the distances of the diagonals. So I actually have to do 6 distance formulas. Sorry. Okay, so here we go. Distance. Let's go the 2 sides first. Oh, and I'm going to mark these on here. This coordinate is -3, 0, just to make my job a little easier. This is 3, 2. This guy is 4, -1. And this guy is -2, -3. Okay, we're just going to make my job easier. So we're going to go, actually, I'm going to go with their work. I don't usually like to use their work, but I'm going to go with their work. So distance formula. They do GH first, which is this top guy, okay? Actually, I don't want to do that. I'm going to write it over here, GH. We'll go the same order as they have, but whatever. I have the square root of GH. I'm going from -3 to 3, which is 6, and I'm going 0 to 2, which is 2. So 6 squared is 36, 2 squared is 4. That's the square root of 40, just like they have there. Okay, now, I'm not going to go in the same order as them. I want to check to make sure that this guy matches this one, right? So I'm going to go KJ next. Okay, blah, 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 blah. All right, -2 to 4 is a distance of 6. -3 to -1 is a distance of 2, and that's the same as it was before, so that's the square root of 40. So those two match each other, and I know that those two are the same, okay? Now I'm going to go the other direction, and I'm going to go my other two. So I'm going to go GK next, which is the left side, okay? And I'm looking at -3 and -2, which is a distance of 1, and 1 squared, plus, and 0 to -3 is a distance of 3. So I have 1 squared plus 3 squared, which is the square root of 10. Okay, now I'm going to do the other side, which is HJ, and I want that to be the square root of 10 as well. So 3 to 4 is what I'm going, and that is also a distance of 1. And 2 to -1, that's a distance of 3, and that's the square root of 10. So check. Now, this only tells me that he is a parallelogram. Parallelogram, check. Now I've got to do the diagonal distances, which is this guy here and this guy here. So I'm going to go from, I can't even see my little markings anymore. Let me get rid of some junk. Oh, come on. There we go. And one more. I got this one and that one. Okay, all right. Okay, so now we're doing diagonals. I'm going to do those in yellow. So I got to go from, let's go from K to H, KH, and let's go G to J, GJ. All right, and we're doing square root, and we're doing square root. Okay, all right, from K to H, from -2 to 3, that's a distance of 5. So 5 squared plus -3 to 2, that's a distance of 5 as well. And 5 squared is 25, and another 25 is the square root of 50. Okay. All right, now going the other direction, I have -3 and 4, which is a distance of 7. But then I have 0 and 1, or 0 and -1, which is a distance of 1. So I have 49 plus 1, which is also the square root of 50. So my two diagonals are the same length, and from checking these two, now I know that he's not just a regular old parallelogram. He is, in fact, a rectangle. Check. Okay? All right, so there's the deal. All right, now I'm going to do one more thing to this thing, and it is proving this by using slopes. Okay, let's prove it by using slopes, which is a little bit shorter of a process, okay? So I'm going to do this by using the slope formula, and I want you to follow along with this, okay? I want to do slopes, because you do have a homework assignment where you have to prove it by doing slopes. So I'm going to go from G to H, and I'm going to go slopes. Now, you can use the coordinates if you want to and do like y2 minus y1 over x2 minus x1, but I'm just going to look at the slopes here. So I'm going from G to H. That's a rise of 2 and a run of 1, 2, 3, 4, 5, 6. 2 over 6, which is a slope of 1/3. Okay, now I want to also do KJ. KJ, his slope is, oh gosh, his slope is going up 1, 2, and over 1, 2, 3, 4, 5, 6. So up 2 over 6, which is also 1/3. Okay, now I know that since those two have the same slope, then that means this guy is parallel to that guy. Great. Okay, but now I'm going to do this guy right here and this guy right here. I'm going to see what those slopes are. So going from here, I'm going from G to K. So let's go GK, and then we're going to go HJ. HJ, and we're going to do the slopes of those guys. So from G to K, I'm going down 1, 2, 3, and over 1. So -3 over 1, down 3 over 1, which is just -3. Okay. Then from H to J, I'm also going down 3 and over 1. Down 3 over 1, which is a -3. Now, the fact that these two match tell me that this guy is parallel to this guy. So, according to this, he is a parallelogram. But how do I know he is a rectangle? Well, he's a rectangle if this makes a 90-degree angle. And this makes a 90-degree angle if these two lines are perpendicular. And these two lines are perpendicular if their slopes are negative reciprocals of one another. So 1/3 and -3, are those guys negative reciprocals? Yes, they are. 1/3, -3. Those guys match. They are negative reciprocals, which means they're making 90-degree angles. So check, he is a rectangle. Okay, so, like part of that process makes him a parallelogram if the two slopes match, but the fact that they are negative reciprocals makes him a rectangle. Kind of like over here, you had to check the 4 distances, that made him a parallelogram. You have to check the 2 distances, that makes him a rectangle. Okay, the deal here over here is for slopes, you don't have to do it like 2 more things to check. You just have to check to see if they're reciprocals, negative reciprocals. Okay, so that's how you check it with the slopes. All right, so you have a homework is like part of your homework assignment. One of them you're going to do this way, one of them you're going to do this way. So if you need to come back and watch this, that would be a grand idea, and that's it. So this is what I have for homework. 1 through 14, all that's the first page, and then 20 and 22 are where you have to do the slopes and the distance formula. You don't have any proofs, I don't think. So you're welcome for that. But there you go. Okay. All right, goodbye.